applied to an open access data set, and then Venkat will show how it is applicable to the TMH histopath images as well. So I will request Raja to begin.
Professor Ganesh, can you give me the access to share the? Hello, am I audible?
Yes, yes, you are. Just a moment.
Yes. Yes, you can present.
You can present now, Raja.
Is my screen visible right now?
Yes, yes.
Yeah, so coming to the major aim of this project is to we will be predicting the count of lymphocytes using a given patch of the whole slide image. So for that, we will be using SPEAR, that stands for the semi-supervised data programming. So basically, we will be going into a 3-step process. So the first step process is ROI, region of interest selection. And the aim of region of interest selection is to output the bounding box for every possible candidate of lymphocytes. And basically, additionally, what we want is a high recall in this process. Basically, suppose we predict the 20 bounding box, we want the actual 10 bounding box to be included in that region of interest selection. And then we will be going over the region of interest filtering. So we will be using data programming methods to filter out the actual ones, the lymphocytes, and then we will pull all the actual ones, the lymphocytes, and that will consequently give the count of lymphocytes. So till now, basically, we have completed the region of interest selection process. So suppose this is the image 1.png. So we have applied the pre-processing method. That is basically a noise removal method. So this is the final image which we got after applying pre-processing on the input image, which looks more smoother than the input image. And then we have a different number of labeling functions to output the number of different bounding box for every possible lymphocytes. So basically, then we have extracted the H channel of the image, and similarly the DAB channel of the image, and similarly the RGB channel of the image. So basically, suppose this is the original image, the hematoxylin channel of the image will give only the blue ones channel of the original image, and similarly the DAB will output the brown stain of that image. So basically, we have used the labeling function. Labeling function is something that can be dynamic in the nature. So as per need, we can add or delete different number of labeling function based on the different algorithm or different hyperparameter which we have. So suppose for say like I have implemented the labeling function one on the H channel of image, which outputs this number of bounding box in the image, and also the add 2D array, which we have the x1, x2, x3, x4. Basically, x1 is the vertical minimum, and x2 is the vertical maximum, and y1 is the horizontal minimum, and y2 is the horizontal maximum. Similarly, we have applied a labeling function 2 on the DAB channel of the image, which also outputs some other bounding box. And similarly, we have applied the uh, same labeling function 3 and 4 on the RGB channel of the image, and we got the different number of bounding box. So basically, we will get all the possible candidate of lymphocyte, and the next step will be to do the RY filtering method. So in the first process RY selection, we got all the possible candidate of lymphocytes, and second step will be RY filtering.
Okay, Venkat, could you then show this same application to the HL
Yeah.
images?
Yes, Professor Shijit. Sir, can I get uh, sharing access? So, Ganesh. Hello, audible?
Yeah,
Yes,
yeah.
yes. Yeah.
Okay, I'm waiting for the share access. Okay, thanks, sir. Got it. So I hope my screen is visible.
Yes.
I will take through couple of problems what we are doing and how we have integrated Raja, Akshit, and other team members' code. Number one is for the WSA slide that Dr. Subhash has given and team has given. We have written a code that can generate patches. So, for example, if I give 20 patches, I can give the count, I can give the zoom in level, I'm giving the least zoom in level of 0.1%. So like that we can change. And what happens is we can get a random patches. So there will be a lot of noises here, of course. So some are black, some are maybe on the border of the brown edges. But ultimately there will be some relevant patch that we'll be getting. I think, for example, this one is relevant patch for us. So that is number one. So given a slide, we are getting random patches because usually random patches helps, but there are also facilities to take all the patches through a sliding window or some of the patches that we mentioned with X and Y coordinates. So all the facilities have been written in that. And now let us apply what Raja has just told to these images. So you can see that I am taking okay, I'm taking a sample which has more of Reed-Steinberg cell. I hope Dr. Subhash, this has more Reed-Steinberg cell and some lymphocytes. Can I see?
Yeah.
Okay, so that one I have just did randomly and saved it for this demo. So that on that we are running some pre-processing. This may not seem relevant, but anyways, I'm just running for to show how this function works. As you can see, some of it are noises. Dr. Subhash, can you tell me how well is it detected lymphocytes if this is one is detected as lymphocyte? There are some noises. We can work on that. But is this a lymphocyte?
That looks a lymphocyte. Then the top one, second box also looks. No, on
Okay,
the
great.
left hand.
This
That
one?
second, even the one which you pointed before also.
Okay,
The
great.
small. These all looks lymphocytes. The bigger ones look RS or H2 cells. But this
Yes.
look
Yes.
lymphocyte. The smaller
So
one.
bigger ones, we will be filtering it out. That's where we Raja might have shown the filter. So what happens is, since we wanted higher recall, we take as much as possible, and then we'll filter it that is not there. So at least we are on the right path. That's good to know. I'll just show one final interesting thing that what Raja has shown. So differentiating them based on different stains. This will be useful for us as far as image processing is concerned. This is one part of the work that we did, where given a whole slide image, we can take any images or random slides as we wanted, patch, and then do this flow that what Raja has shown. Maybe in a couple of weeks, we'll have a proper output of how well it is doing that. This is number one. Number two is identifying Reed-Steinberg cell. So let me run. So this is the patch image. We use some labeling functions to identify the with some hyperparameter we are trying to identify. So as you can see here, Dr. Subhash, some of it are identified, some of it are missing. This is only
Yes.
yes. So we have written only one labeling function. Couple of we are still writing it. This is for filtering from that for Rein-Steinberg cell, and another one is eosinophil cell. So there also we have written the two codes. But ultimately we are, and these are the things that we want. We are trying to add up together. Now I wanted to bring how it comes thing all together. Just wanted to show the big picture again. So here we have done some ROA selection. We'll write more labeling functions based on the inputs we have given, and also ROA filtering and ROA pooler. And once this is done, we will send it to you, Dr. Subhash, and we can have a qualitative check. How much is missed, how much is not missed for some random patches that you think is right.
Yeah, I have some queries
Yes.
for. For Raj. This program, which labeling function it was developed on what set? It is some available data, open database, or was it developed on the TMS data which I had given you? The lymphocyte. See, because lymphocytes can be of various types, and I want to know like how there are other cells like plasma cells. How did you segregate those? Because they are also similar in size. If you are using a size function, then that is also similar.
So we used open source
This is
data.
unsupervised.
Achha,
This is unsupervised.
this is unsupervised. Okay.
I wanted to show you, maybe it is not technical, but let's just take how we are doing it. It will help one way. So we do some kind of pre-processing. You can see we take that in different shades. The same patch we take in different shades, and for each of those different shades, we run this labeling function based on some heuristics approach. There is something called as connected components. These are computer vision problems that is applied even for face detection, object detection, but we are also applying it here with some of the knowledges that you gave as a, if you remember the document that Umesh shared, that was really useful.
Yeah.
So based on that, we are doing it, and the data set as is before applying it to Hodgkin lymphoma, we are also applying it to open data sets. That is one of the data set is LIS2.
Okay. Yeah.
But our goal is to generalize the heuristics as much as possible so that it works either ways.
Yeah. So the results which you showed looks nice. I mean, they are quite impressive, but we need to refine them.
Of course, yeah,
We
sure.
refine them more because there are some outliers that I can see in the images. So
Yes.
So Dr. Uma is also there on the meeting. She is my colleague and she is a hematopathologist in our hospital. So myself, Uma, and Dr. Sridhar will do the validation part of this primary model, and then we can utilize it for our HL cases.
Absolutely.
Yeah, just to chime in, Dr. Subhash, is that we are so this, if I'm not mistaken, Dr. Venkat, it's just one labeling function right now that you have applied, right?
Yes.
And we will have multitude of them so that
One
we will
template. One
Yeah.
template with a lot of instances, right?
Yeah, one template with right, and we will have multiple such labeling functions so that there is a high possibility that we will not miss a lot.
Yeah.
Yeah.
So
And
one more last meeting we had discussed some regarding CD3 and CD8 also. There were some available functions of a labeling function for CD3 and CD8. You all only had showed us.
yes, CD5
So,
and CD8.
CD5 and CD8. So in like what I see in the force side, that in future will have to apply those also in our function so that we get more segregations, like, because the lymphocytes are CD3, 4, 8 positive, and that will also help us that
Yes,
way.
yes. So, Dr. Subhash, I wanted to show this part alone. This is where it can be HNE or CD, any of the CD series. What we have done is segregated based on the stain color, and we'll apply the templates for all of these four. So either H or E or the CD8, which is brown, we are confident that we can be able to apply those templates.
And we could manage color normalization uniformly for all the cases, like if it's based on the color function. So all the slides, the images which you use, the patches had uniform color normalization. Everything was done in the pre-analytical.
Yes, yes. So, I mean, that is why we wanted to show this. What Raja showed was on a general data set, and what I'm currently showing is on the data set that you shared. So
Yes,
it's working pretty well. So, for example, I can now show you how it works for CD50 or CD. What is the other one that you shared?
30, 30.
CD30, right? Yeah. So let's check how the segregation happens even now. So you can see one patch is selected from that. I'm just going to go skip all this and go here. Yeah, you can see that again it is able to, not so very clear, maybe the hematoxylin because it does not have a lot, but DAB is able to segregate. I wanted to show you the patch as well. I think it's 18. Let me check the patches. Give me 1 minute. So patch 19, right? So this is one, and this is the actual patch 19 taken.
Yeah.
Yeah.
So I mean, we are testing it now. We haven't tested it on CD50, and it looks okay, right?
No, it looks actually the one which you showed before this. It looked pretty good actually. So if we can fine tune and channelize properly, I think we are on the right track. And once the patches are ready, so these will be 256 by 256 patches you're testing.
Currently, yes, currently. So
Yes.
our goal is to look at the different zooming level and different sizes as well.
Because I think we'll have to go to 1024, I think, to check at all different levels. And once the patches are ready with all these labeling functions, then me and Uma can have a look at it. But it looks quite impressive. Venkat. Yeah, it looks good.
Subhash, could I ask you a question? You said we need to go to 1024 level. Is there a specific reason?
Because
Are you? Yeah.
no, but look, not specific reason. What we have function in our other project, there's a lot of when it comes to validation, because the sizes for us, it becomes so much of zoomed up images when we do
Okay.
validations.
Okay.
So we noticed that we were actually either overcalling something or something like that, because we'll be seeing the patch, HME patch. So the same cells looks quite large. So when we also have done a recapture project, and in that we had to shift it back to 256 later on, because it was giving little normal what we see under the microscope. So I'm just saying the function, whatever we make, should be applicable at different levels. It's not that exactly at 1024, but it should function at all different patch levels.
Okay. 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 Thank you. Okay. Venkat, I think, yeah. Should we request Atharva because Dr. Ashish is also here?
Yes.
So Atharva will show his segmentation for the CT scan images.
Yes, sure. Can you just give me the share access?
Let me check if I can give.
Yeah, I was just checking that.
Yeah, I can do that.
Yeah, perfect. I think Professor Ganesh left, is it?
Yes, I maybe, yeah, connection lost or something.
Yeah, he's back.
My screen is visible, right?
Yes.
Yeah, so main objective of this project is to find like the small objective which we are working right now is to find where exactly tumor has spread using the combination of PET scans and CT scans. So right now I have created a module where we can segment if given a CT scan, if it is in the region of head, neck, thorax, abdomen or legs. So this is the small demo which I will like to show. For example, if we have image files. So these are some of the CT scan images which we have. and we want to segment it using these 4 classes. For example, this image is in head, neck, and these are some of the images from abdomen. So what code does is it classifies, given a folder of images, it classifies each image into either of these 4 classes. So for this, I have used a small amount of training data, wherein I have 4 classes right now. We can increase number of classes according to our objective, and it calculates cosine similarity between the input image and each image in the training data, and based on that information, it classifies it into either of these 4 classes. So, and it creates a folder where it copies each of image in specific folder corresponding to the class.
Are you going to give a live demo?
Yes. So,
Okay.
So it takes around 1 minute to classify entire folder.
How many images is it?
Uh, 834.
Okay, nice.
So right now it uses cosine similarity, but we can train a CNN model as well. Just that it is this cosine similarity is very modular. We don't require any training as such, and it works reasonably well.
Could we also try with like we discussed in the morning, Dr. Venkat, if Atharva could also try with a small CNN and see if we have similar accuracy or not.
Yes, yes. So that would be
Try
the
with small what?
I didn't hear Dr.
Sorry,
Professor.
try with small what? What was try with small what?
A convolutional
CNN.
a CNN.
Yes.
Okay.
So currently it's cosine similarity. The next step we are thinking is to have some deep learning network as part of this.
So cosine similarity for classification, is it?
Yes. Yes.
It's almost nearest neighbor. You're saying train a CNN rather than just nearest neighbor, right?
Sorry, Ganesh, we're not able to hear you.
You mean currently it's based on CNN nearest neighbor, right? The current classification is based on nearest neighbor, is it?
Yes.
Yes.
Is it done?
Yeah. So
Okay.
after this code is complete, it creates this classification results folder and copies each of the image file into a specific folder according to class.
Yeah. So Dr. Ashish, last time we had shown that Atharva could automate the SUV max in each image. And now, right now, what he's doing is he will be classifying the input images into the 4 subcategories. The next step actually is to identify the organs within each subcategory that he has classified them into, and we'll be working towards that before the next meeting. And the final goal would be to then, sorry, go on.
It looks great. I think even cosine function works very well. And I saw that the images are able to segregate the image of it neck.
There's some echo, Ashish. There's some echo. We can't hear you well.
Are you able to hear me now?
Yeah, there's
Hello?
some echo. Yeah, but okay, go on.
So I saw the image and I think it's working very well. And that's
Okay.
I believe that's I think nice approach to first segregate the image in various parts, and then you identify the organ in that area, and then this any abnormality.
Yeah, so that is exactly the plan. So now that we have segregated it into 4 groups, we will try to within each group whether we can identify the organs, and then whether we can overlap it with the PET SUVmax data to identify which specific organ it is. That is the workflow for the next few weeks. Atharva, are you on board as well, Atharva?
Yes.
Yeah. Okay, so this is what we had to show, Professor Ganesh. This is what we have done. Not we, rather the students have done.
So just to add, like about the lymphocytes which you are looking at, because there is a lot of role of tumor infiltrating lymphocytes in other cancers also. In addition to all this lymphoma we are doing, but there are in other epithelial cancers also there's a lot of them. There are some already published AI models also, so it will be useful for us for even for other cancers.
Perfect.
Yeah, because I think I saw some papers from the Norway group and all, and we also report histologically when we are doing our reporting that it's how much is mild, moderate, or severe. But if we can quantify them, that will also be good for the great model. Yeah.
Subhash, there's one question that I had specifically for you. We also are going to look at the microarchitecture of the slices, right? Am I audible, Subhash?
Yeah.
So we are basically also going to look at the microenvironment, right? So we would need to do some sort of brainstorming together to identify certain discernible characteristics, which then can be coded in. So when could we meet to do that?
Somewhere in the next week or in the first week of Jan. I mean, this you take a call. This week I'm not there for next 2 days. Next week I'll be there.
Okay.
Or in the first week of Jan. So whenever is comfortable, me and Uma can sit with you, and we can do it. So microenvironment, you mean the background cell, the stromal component?
Yeah, so in the research proposal that was written, if I understand correctly, you were also going to look at the microarchitecture, right? Just not based on the Reed-Sternberger cells, but even the
Yeah. So microenvironment means we mean the adjacent population. Which one is which we are looking at is eosinophils, neutrophils, lymphocytes, and along with that the stromal component, because some of the Hodgkins have a lot of sclerosis.
Right.
So that becomes the background. So all that, yes. That all should be.
So what I understand well is that, and Dr. Venkat could also chime in for this, is that we have a system in place to identify eosinophils as well, right?
Yes, I mean we have written some labeling functions that will help us identify that.
Yeah.
And does it help to distinguish between neutrophils? Because see, both neutrophils and eosinophils look same. There's a difference in the one is bi or multi-node. So they're quite similar in terms of their sizes and all other characteristics, except for the granular function is different.
Right. Yeah. So basically, the cytoplasmic architecture is a bit different, right?
Yes.
So we will, Venkat, actually what Dr. Subhash is saying is that once, like, the granular structure of the cytoplasm is a bit different between these two, and maybe we could actually think of a programmatic way to distinguish this. It will take some time for us to think about it, and maybe some more insights from Subhash's end will also provide some heuristics to identify that.
Sure.
Yeah. Uma, you want to add anything? Uma is there on the call. She wants to add anything.
If Umesh is not adding, then one question I have is this the granular structure of at the cytoplasmic level? Can that be in the form of some additional supervision? So instead of pretending completely non-supervised, we can always look for weak supervision, right? So I think Venkat and Kshitij, it's food for thought for us.
Yes,
right. I mean, even the work that Raghu Makiraju from OSU did was weak supervision. We have directly jumped to unsupervised. Maybe we can look for some intermediate supervision. Right. For the granular structure of the cytoplasm.
Yep.
Very
Yeah.
At the
interesting.
So when we do at microscopy, the eosinophils have little larger and coarser granules, and the neutrophils have very fine granules with maybe occasional little coarse. But under microscope, the granules, the granule texture is not seen that much in neutrophils. But eosinophils, you can make out that this is little granular texture, a little larger, denser cytoplasm. Like it will look more dark and dense and more orange color. It takes up the orange color in HN that way. So
Okay.
these are the certain differences.
Okay. Okay. Yeah. Yeah. Okay. Professor Ganesh, I understand. I think Venkat and we could think a bit more deeply about it, right, Venkat?
Yes, yes, yes. In fact,
Yeah.
so Ganesh, this is where we wanted to see how we can use the IOU based approaches for weak supervision. So trying to bring consensus between the labeling functions and some few label data with an in-deep model.
Perfect.
Yes,
I
please.
think,
Perfect. Got it.
yeah. So this is what we had to demonstrate, and the task for the next endpoint is the next week's meeting is also discussed by us previously. So Atharva is going to try to find basically code in how, for example, let's focus just on thorax to begin with, Atharva. If we can identify different organs within a thorax, right? Instead of trying to strain ourselves with all the four classes that you've already identified, just let's focus on thorax, because the spine and the lungs would be a major place where we want to identify. Am I right, Dr. Ashish?
Yeah, agree.
Perfect. And Subhash, I will call you in a bit if it's okay, and we could also discuss when we could meet, and then from there take it forward. Okay.
Yeah, definitely. So if whenever we decide, then I'll arrange the slides so that we can see together under microscope.
Sure, sure. So like you
Also,
would
it may be a good idea to make a physical visit before the semester starts.
exactly
Just a thought.
exactly that's what I was actually getting to. Since we have to sit at the microscope together, we'll probably have to go. Yeah, and
Yes.
I will get Raja along as well. That way it becomes
Yeah,
much
that
easier.
will
Yeah.
it will be helpful for you to understand because the photographs and all that is not that nice. And to start with, it's better to see under the microscope, identify. So Chandan and that time we had one session. Chandan and Ashish had come. I think that
Yeah.
we had one session. It would be good.
Subhash, I will come along. Not a problem.
Yeah, definitely.
Perfect. Thank you very much. So these are the updates. If anybody wants to add something, please do.
Also, one more thing, Umesh, maybe if you help coordinate. So the MOU is finalized from both ends. I think Kshitij, if we can just share the MOU once with respect to our team. I'm assuming it's all fine, but maybe through Dr. Hasmukh Jain and Dr. Subhash, they go over it once. I personally feel we should just be clear with that so that we can really also plan publications.
Right.
Be done with the MOU so that publications can be the next line of sight, right?
Sure.
So Umesh can coordinate that. Umesh, please see to it. That's regarding the MOU thing which Ganesh is asking. And I agree, like the work we are doing has to come out as a scientific paper first. So that is there. That has to be done.
Quick
Right,
question.
exactly. So, so I think the MOU is already cleared by, just for your information, the MOU is cleared by both the legal teams, IITB as well as TMH. It's an umbrella MOU covering 4 or 5 projects. So it's just a bit of maybe some due diligence if we want to make for our specific project. I have looked at it. I see no issue. We should just close it. So Umesh, try and close it in a day because we should not delay. Because the legal teams took so much time. If we also take more than one day, it will just be unfair to our own efforts, right? So Umesh, try and close it in a day. Just follow up with everyone. Just close it in a day. To me, it looks like it's all clear.
Okay, sir.
Yeah. Yeah, Subhash, quick question. Would you have more images to share with us, or how is it?
So
Have you
right
just
now,
shared? Yeah.
no,
Have
we
you just
share-
shared a few, or have you shared all that you have?
no. There are lots pending with me.
Okay.
So I have shared, I think 25. Umesh, we have shared 25 cases with them. So last time, actually, we had removed some 37 cases, which had around say 50 odd slides. But then there was exclusion criteria of age of 15 years.
Mhm.
That only more than 15 years. So we had to exclude some of our cases. So we are ready with 25 cases. I think that is shared also. And we have another batch which is going to get ready in a week or so of another 25. Umesh, 25 or 27. So that is also. So that another batch is ready, and then
Okay.
in batches we will keep giving you say 2 or 3, at least 2 to 3 more batches. So we need a number of say around 100
Okay.
WSIs. That will
Okay.
be thousands of batches.
Perfect. Great. Great. Actually, Venkat, I think we are still good with what we have because we need to do a few iterations at our end as well. So
Yes.
yeah.
So sorry,
More
I have some visitors now. I just have to leave the call.
Yeah, we are done actually, Ganesh. So
we are
Okay,
yeah.
okay, thanks.
Yeah.
Thanks.
Okay. Good to see you. I hope we see you again next week.
Yes.
And Subhash, I'll give you a call in a moment. Ashish, nice to see you again. I hope you're happy with the progress that is being made.
Yeah, I think it's progressing very fast.
Yeah, great. Awesome. So we see you soon. Thank you, Dr. Venkat. A lot of actually this is driven by Dr. Venkat. So thanks a lot.
Yeah. Thanks everybody.
Thank you. Bye-bye.
Thank you, everyone. Bye bye.
Bye bye.